Okay, so the next material we're going to be looking at is a refractive one, and the refraction pin in here. Refractive materials only work with a translucent or additive blend mode, so we're going to be using translucent in here. And so if we think about what might be happening, if I plug in an opacity value of 0, I can't see anything. Let's plug in an opacity value of 1. There we go. Now you can see I've got my plane here. So I have my translucent material, and I want to make a sort of refractive material that has no opaque qualities whatsoever. So for something like a heat haze, or where you have heat distortion, anything like that, you definitely want to have no opacity. You don't want to see it. If you're doing sort of frosted glass, you'd maybe have some opacity, but there's times when you definitely want to have something that causes refraction that doesn't have any opaque element. And so an opacity of 0 has to make sense for our refractive surface. So what does that mean? Well, if we plug in our refraction value here, and I'm just going to set this to be a value of 1. Refraction is a measure of the bending of the light as it moves through surfaces of different medium or different densities. So the classic example of a pen in a glass of water, in fact I can probably bring it up, refraction, classic example of a pen in a glass of water. The pen appears, or pencil appears, bent because the density of the water is different from the density of the air, and that's what causes refraction, and that is in this case what we're using as our value. And so the refractive index, and you can get refractive index charts all over the place, including Wikipedia. The refractive index, if I find it down here, some examples, I believe. No. Refractive index. There used to be a big table in here somewhere, maybe it's on a different website or a different page on Wikipedia, but they are measured values. They are a ratio of the density of air and the density of the medium that you're trying to make. So if I put a value of 1 in, that means no refraction, because we're now saying that this density of the material, in this case this plane, is the same as the density of air. Well, we don't see any refraction. If I plug in a value really high, a value of 5, you can see that the surface, or that the plane here, has bent the light, so the windows no longer line up. That's on a cube on the plane. Let's try atmosphere. There we go. And you can see that's having that effect. A value of 0 is going to be bending the light the other way. So you can have materials that are both denser than air or less dense than air. We don't find many materials less dense than air in sort of the physical world around us, but for magic effects or shock waves or stuff like that, you might want to be able to do this. Important thing to remember is that a refractive value of 0 is quite a lot of refraction, and a refractive value of 1 is no refraction. And so it's not a case of working on a sort of 0 to 1 scale like you would with sort of intensity. Refractive value of water is 1.33, but to be honest, it's very much, at least I'm very much of the opinion, if it looks right, it is right. And so although I'd start with 1.33, I'd probably tweak it to suit, depending on what effect I was trying to make. A little bit goes a long way. Now you might notice, if I take out my refractive pin, I don't have access to a normal map, because we're using translucent and volumetric non-directional. Normal map isn't supported, but if I put refraction in, suddenly it is. So we can use a normal map to define a surface just for refraction. And you can see here we're seeing these kind of brick normals. So if we were doing some kind of heat haze, I think I've got some normals noise, yes I do. You can see now we've got a kind of a bumpy surface, and if I just quickly animate that, we'll cover Pano in another video, but if I quickly animate that, not that fast, we can get a nice kind of approximate value for sort of heat distortion, that kind of thing. It's very intense, as I say, a little bit goes a long way. You can either lower your normal or lower your refractive value. I think, there we go, yeah, pretty subtle. Let's see if that's coming through on the video or not. I'll just up it slightly. And you can see, especially if you look at the top here, we're getting that nice distortion. And there we go. So if you want to use your normal map, or if you want to control the distortion with a texture, the way we do that is via the normals. And if we want to have a value of no refraction, we put that to value of 1. That's the sort of physically accurate approximation, but actually there are 2 types of refraction. If we scroll down in our details panel down here, there's a refraction setting, and we can change this to either use index of refraction, which is sort of the physically based measurements such as we had here, or pixel normal offset. Now in this case it's not going to make a huge difference, but basically now we're doing a screen space effect rather than a more physically accurate one. What do I mean by that? Well, if we go to the documentation, some really good examples of using this. For large flat surfaces where you want to have refraction, a pixel normal offset result can work a lot better. If we have a look at this example, it's just going to blend in, isn't it? That's not the one I want. They've updated their documentation. That's really interesting. Okay, fine. Basically what can happen is the index of refraction for flat surfaces can refract the object to the point where it's still, but becomes visible in its own refraction, which doesn't make any sense. Again, everything we're doing in real-time rendering is fake and approximate and optimized. We can't afford to do full path tracing and anything like that. Not if we expect to get any kind of frame rate. And so the index of refraction model works really well for solid objects, glass vases, that kind of stuff. But for large flat bodies of water or glass, less so. You might start getting errors. So pixel normal offset distorts things. There we are, this is the current example. So you can see here the distortion on the glass windows. This chair has been distorted from here outside almost, which isn't how refraction works. It would be distorting what's behind. But then if we use pixel normal offset, now we get our refraction affecting the windows correctly. So worth checking out the different methods and seeing what works for you. This would be index of refraction and this would be pixel normal offset in my experience. So worth knowing about for sure. Cool. All right, that's everything on refraction.